All right, welcome back to our flipped lessons. Today we're going to start talking about percents and estimation. Percents are something that we're going to talk quite a lot about in our lives. We talk percents when we're talking about sales tax. We talk about percents when we're talking about tips. We talk about percents when we're talking about interest rates. So percents are something that are very realistic to our daily lives. But we're going to begin today with estimation and how to estimate percents, which is going to be a really useful thing to know how to do. So we're going to learn how to estimate the percent of a number and find percents that are greater than 100 or 1. So let's start with a quick review of what a percent is. A percent, okay, that's the symbol for percent, is known as a part of a whole. Okay, it could be a bigger part of the whole, or it could be a smaller part of the whole, or it could be less than a part of a whole. So it's a part of a whole. We know that percents are always calculated out of 100, whether they're greater than 100 or not, and they're equal to part of a whole. Now this proportion here is something we're going to talk about a little bit more later on in the week, but today we want to focus on that percent ratio that we talked about in class yesterday, but realizing that the whole is always equal to 100%. So let's look at an example. Jodi has paid 62% of the $500 she owes for her loan. Estimate 62% of 500. So when we're estimating, we're trying to calculate very quickly in our mind what the actual answer will be. So for example, if I'm at a store and I want to buy two items that cost $18 each, I might think, well, 18 is really close to 20, so that means that I need at least $40 to be able to afford this, especially when tax and all that is added on. So whenever we're estimating 62% of 500, I'm going to do the same kind of thing. I'm going to look at that 62%. I'm going to say, well, that's really close to 600% of 60% of 500. 62 is very close to 60. It's easier to work with 60 as a nice round number. So we know that 60% is going to nicely reduce down to 3/5. That's 60 out of 100. I can divide both the numerator and the denominator by 20, giving me that 3/5. We know that of is a multiplication type problem, so anytime we see that in a word problem, we know there's going to be some kind of a multiplication happening. So 3/5 of 500, that's going to give me 300. Well, to quickly review how we got that, 3/5 of 500, we can multiply straight across, giving me 1,500 over 5, which equals to 300. Or for those of you that like to cross reduce, divide both of those by 5, giving me 1 and 100. 3 times 100 is 300. So in our estimation, we find that 62% of 500 is about 300. We know it's not exactly 300, but it's about there. So we've estimated what we should be finding as an answer, very close to what we should be finding, but we know that our answer is going to differ just a little bit if we were to calculate this exactly. So let's look at another example. So this one's a very realistic example of what might happen if you go out with your friends to buy pizza. Marita and 4 of her friends ordered a pizza that costs $14.72. She is responsible for 20% of the bill. About how much will she need to pay? Since it's her and 5 of her friends, each of her friends is responsible for 20% of the bill. Well, if she's trying to calculate this based on what she can do without paper, pencil, or calculator, she's probably going to estimate out that $14.72 is approximately $15. That way she ensures that she has enough money to pay and possibly get some change back. So $14.72 is about $15. That 20% is a nice round number to work with. So I'm looking for 20% of 15. So we know a percent is always out of 100, and of is a multiplication operation. So 20% of 15. Well, I know that 20 out of 100 reduces to 1/5 of 15. When I multiply straight across, that's 15 over 5, which equals to $3 that she owes. Now for those of you that like to cross reduce, again, I could have cross reduced right there and there. 3 times 1 is 3. Okay, so we know that Marita will need to pay about $3. It'll be a little under $3, but $3 should cover the bill. Okay, so sometimes you need to estimate percents that are larger than 100%, which means that you're going to have a number that is greater than what you're estimating that part of. Since 122% is a larger part of 50, this could be an example of you owning a store and you're selling an item. You buy it at $50, but you want to sell it at 122% of that so that you can make a profit. So let's go ahead and get started. So if I'm looking at 122%, I know that rounds down to 120% of 50. Well, 120% we can break down to, that's 100%, and that's 20% put together. That makes 120%. So that means that I'm looking for 100% of 50 and 20% of 50. So 100% of 50 and 20% of 50. Well, that and we know is just an addition operation. So 100% of 50 is going to be 100 out of 100 multiplied by 50. 20% of 50, that's 20 out of 100 multiplied by 50. So that's going to be 1 times 50 plus 1/5 times 50. Well, that's just going to be 50 plus, well, 1/5 times 50, that's going to be 50 over 5. That's just going to be 10. So we know that that's equal to 60. So 122% of 50 approximately is equal to 60. All right. Now, this problem is a little trickier. There are 789 7th grade students at Washington Middle School. About 1/4% of the 7th grade students have traveled overseas. What is the approximate number of 7th grade students that have traveled overseas? Well, to start off this problem, I have two numbers here that are going to be easier to work with if I round. I know that 1/4% is not equal to 1%, but I know that 4 times that is equal to 1%. So let's work with 1%. And 789 is approximately 800 students. So I'm going to estimate with this number. I'm going to calculate with this number because those are going to be easy numbers to work with in my mind, but I'm going to need to go back to, well, I was looking for 1/4% when I'm all done. So I know that 1% of 800 is going to be calculated at 1/100th multiplied by 800. Well, that's just going to equal to 800 over 100, which equals 8 students. So what that 8 means is that if 1% of the students had traveled overseas, that means that 8 students would have traveled. But we know that only 1/4% of those students have actually traveled overseas. So what I need to do with that number is, well, 8 divided by 4 is going to be equal to 2. 2 is 1/4 of 8, so 1/4 of 1 is equal to 2. So that means that 2 students approximately have traveled overseas. So we're just going to say have traveled. And you and I will understand that that means traveled overseas. So that being said, with a problem like this, you're going to want to take your percent and you want to estimate it at 1% because it's much easier to work with 1% than 1/4%. Because 1/4 equals to 0.25, so then 0.25 out of 100 is just harder to work with. Okay, so let's try another problem that's similar to this. Last year, 639 students attended a summer camp. Of those students who attended last year, 0.5% also attended summer camp last year. About how many students attended summer camp 2 years in a row? So when I'm looking at this problem here, it's the same type of situation. I have a not so nice round number of students, and I have a number of students, a percent that's not even a whole percent. So let's think about this. So I know that 0.5%, if I multiply that by 2, is equal to 1%. So let's work with that 1% again. And we know that 639, in this case, well, that's roughly 640. So let's start estimating. 1% of 640. It's going to be 1 out of 100 multiplied by 640. Let me make that clearer. 640. So that's going to be 640 over 100. Well, that's just 6.4. But I know that I'm looking for half of that. So 6.4 divided by 2 is equal to, well, I know that half of 6 is 3, half of 4 is 2, so that's going to be 3.2, which is going to be, we can't have 0.2 of a student, so let's estimate that down to, round that down to 3 students who had traveled to summer camp twice in a row, so 2 years in a row. And there's our answer. Okay? On to the problem of the day. This will be the first thing that we look at in class tomorrow. And feel free to go back and watch any part of the video. Your 22% here is not written as a number, but you certainly know how to do that. Okay? Have a good night, and I'll see you tomorrow.